next up we have Daniel talking about some of the newest work we've done around the logging ingestion pipeline.
Thank you. Thanks, guys, for the previous presentations. You gave me a really hard job now that I have to keep the standards. So bear with me. I'll try my best. So before we start, before we dive in, I want to ask you all this question. How many of you have been in an incident room channel with maybe 50 other pair of eyes, where every second counts as you scramble to find the root cause of a problem? Maybe you are in one right now. Now think for a moment about the feeling of the aha moment when you finally find the log line that pinpoints the problem. It feels great, doesn't it? I knew it. So today I'm here to talk about how our team built a log ingestion pipeline for Shopify Scale. You are going to hear Scale a lot of times today. Right, so I'm Daniel Oliveira. I'm engineering manager in the observability team. I have been with Shopify for 6 years now, moving towards to the 7th. Okay. In the past 3 years, I have helped building the observability org and the migration of the metrics and monitoring vendor. And more precisely, over the last 2 years, I have been primarily focused on the logging vendor migration. So our agenda for the next 25 minutes look like this. We start from the pipeline overview, and we are going down to components of the pipeline, Shopify Scale, technical details, challenges and solutions, lessons learned, and conclusion with questions. So when our team was first assigned to this project, we began by asking questions like, how difficult is to build a logging pipeline for Shopify Scale? Spoiler alert, it's quite difficult. How one can define what is a logging pipeline? So we came up with some definitions. The first one is a system that collects, transports, processes, and stores log data from various sources. It centralizes log management, enabling efficient monitoring, troubleshooting, and analysis. These are very fancy words, but it's basically how we transport bytes from point A to B. We also came up with a purpose description, so empower users with seamless access to comprehensive log data, facilitating proactive monitoring, troubleshooting, and data-driven optimizations for better operational efficiency. So basically, we need to give users the right information for them to make decisions fast based on data. So that's beautiful, but how can we unpack those fancy words in a way that an engineer can build and design something, right? Based on a few keywords like collect, transport, and store. So the first step was to define the high-level components and understand the flow of the data. At a higher level, logging pipelines look quite simple. We just have a few moving parts, and there is basically three group of actors. Who produces the logs? They might be from internal or external sources. Who transport the logs and move data from source to the target or destination, and where these logs are stored. This is a super high-level diagram. Next one. So bear with me, the color code, I would need another 30 minutes to explain, so just keep in mind. So this diagram demonstrates the flow of the data from and the components involved in an ingestion to ingest a log event. So at the left-hand side, you have, I would say, mostly all the possible sources that we have in Shopify. Then we have all the transport services, starting from the forwarder, aggregator, entry point, and finally we have the storage, where the data will live until the policy retention expires. So take, for example, the Kubernetes apps logs. So the first step is for vector forwarder to collect the data, reading file system, Kubernetes logs. Then this component sends these logs to the vector aggregator layer, where the data is enriched and batched. And finally, they make to the logging API, which is the very last step before the data syncs into ClickHouse. Another example is Cloudflare, and I believe this is the only source that we have externally to Shopify infrastructure. And as you can see, although the data is coming from the outside, the path follows the same shared components. It even has one last step. So let's look into each of these major components. First of them, data sources. We basically have 5 different data sources. Together, they represent more than 6,000 distinct services across the infrastructure. And you can categorize them like applications, logs, infrastructure, logs, security, server, and edge. Every time I mention edge, that means logs coming from the outside. Then we have the transport layer. If you still remember the transport components, we have here vector playing very specific and important roles. The first one is the vector forwarder. This is the service that runs in every single node and collects logs like from Kubernetes, file system, or journal-D. The list goes on, but these are primarily the log sources. Then we have a second layer, which involves batching and enrichment. This is also done by vector services. And also, aside of these two first ones, we have vector logs router. So this router basically exposes an HTTP endpoint to the external world, and people can push logs as soon as they become available. Cloudflare is the most important example that pushes logs via HTTP. Right, the other important transport component is the logging API. This is the last step, as I said before. The log is stored in ClickHouse. It does not matter what path a log event has taken. It will always land at the logging API endpoint. This is a solution that we built from scratch in our team. As Elijah also mentioned, I'm proud myself for being but I was the first committer of this repo and built the first version of the collector API, which is now logging API. It is scalable and reliable. It plays multi-roles. We can ingest logs via HTTP interface, but we can also consume the logs directly from vector. It is extensible in regards to how we can transform the data, how we can transform in-flight data and process them. And one of the most important features is it is schemaless. So that means we do not force logs in any source to be restricted to any schema. As soon as they have a JSON format, we can ingest them. And finally, we have storage. And it's not surprised that we have here the almighty ClickHouse as the storage system. ClickHouse is a columnar database which delivers high performance, has optimal compression for data at rest, and it allows us to keep data and logs stored in GCS for over 30 days. 30 days here is just an example because it's our default retention policy. But we have specific cases where data is kept for over 1 year. And again, it's another nice open source project and great opportunity for Shopify folks to contribute back, and as we do for Thanos, Prometheus, and so many other nice open source projects. Although it's C++. Okay, and just a quick recap from the previous diagram. And I don't want to mention every single source and the path, but we have logs that are consumed straight from Kafka. That's a very specific core use case in Nginx. And in that case, we bypass vector because the log API, or what we call consumer API, can actually read directly from Kafka and do the same batch processing, transformation, everything built in. We don't need external components. And that was a recent change that we did, which allow us to reduce cost. We don't need extra compute and so on and so forth. And also improve the resilience of the pipeline. Scale. Let's talk about scale. We learned the hard lesson while building observed metrics, right? You have heard this word many times today, and we are going to listen even more. And we knew from the get-go that the biggest challenge would be Shopify scale. So let's look at some numbers. So this is just 3 metrics that give us how much data, a sense of how much data is produced by Shopify on the daily basis. These numbers alone might not say much, so I'll give you some perspective in a moment. But if you look at the top 2 ones, we are mostly, give or take, ingesting 46 gigabytes per second, and that means 26 million lines per second in total across all services. And core structured alone is 12 gigabytes. Right, some perspective. Sources. We have over 6,000 internal services, more than 400 Kubernetes clusters, and as Andreas pointed out, this number goes up and down all the time. We also have external logs coming from Edge, and what that represents in terms of volume. It means 26 million lines or 46 gigabytes per second. And how we can translate that into real numbers. It's like you are copying the Lord of the Rings trilogy almost 7,000 times per second, not a day or minute. And it's 0.72% of the digital collection from the Library of Congress in the United States. This is per second base. It's impressive that we only need 5,000 CPUs. Thanks, Andrea, for us. Now we can offset that CPU for the logging pipeline. And that means 40 terabytes of memory, more or less. And it's not a surprise that all those metrics and many more are all in Observe, where we also use the SLO logs, all the nice features that Erin presented earlier. Thanks, everyone. Right, next topic on our agenda is technical details. So this product or this pipeline was designed considering 3 major pillars. Scalability, it can be scaled to follow Shopify traffics, including flash sales, BFCM, and projected growth. That was kind of a requirement when Elijah just talked to me. We need to build something that can scale over time and be cost effective. The second one is reliability. So we have a message queue system implemented that allow us to retry, replay, and control back pressure. So we have ways to control if a log is not written to ClickHouse at the first time. We will be retrying these writes until or forever, actually. So we can pretty much rely heavily on the pipeline. Security, not surprised, but there is a requirement that we need to access control to certain logs, and in Shopify they are called restricted environments.
It needs to be fast too. That's what I think we expect of it, right?
True, yeah. Next slide. Right, some more of the technical details. Logs are enriched in different points of the pipeline, so there are many places where we need to add extra metadata or enrich the data for users to be able to query them in Observe, like where this log was generated, in which pod, in which cluster, and so on and so forth. Data is retained by default for 30 days. That was a big win for this new infrastructure because that wasn't the case for previous vendors. We have very limited retention. although we were still in compliance with legal, but on a user perspective, 30 days is super nice instead of 7 or maybe 14. There is no single point of failure. We deploy multiple ClickHouse clusters to spread the load and mitigate blast radius. Here we go. Low latency between log generation and availability. It varies a little bit. If you go to observe, it varies a little bit. If you search for core structured, core, Nginx, catch-all. But for Nginx, for example, we have a latency of maximum 2 minutes from the moment the log is produced by the pod until it's available in observe. We are completely in compliance with Shopify's legal requirements. So the retention is just one example of the legal requirements, but access control is another one. We also have mechanism for dealing with failures and ensure data consistency. So as I was mentioning, the pipeline is ready for all the sources to be retried and replayed if that's necessary. We can slow down ingestion for a certain period of time without worrying that this log will be lost, because you can replay and retry them as soon as the infrastructure is back up. All the compute is allocated to optimize the resources. For example, depending on the workload type and their role, we deploy them in certain instance type. Some of them are more memory efficient, others are more CPU efficient. CPU efficient, so the cost is balanced. We don't have one generic instance type that handles everything. Cool. I will not leave this talk without talking about challenges and solutions. So let's talk about the challenges we faced and how we overcame them. Volume. Yeah, that was the very first one. And one way we overcame this is by having a multi-cluster topology. So this way we can spread different logs across different clusters, and when we have to roll out upgrades, the disruption is minimal. Latency. The pipeline, or mostly the logging API, was built in a way that we can fine-tune some of the ingestion variables. Depending on the index, for example, of the volume, we can make the data more fresh in observe or less without extremely affect the ClickHouse writing operation. This is kind of tricky. We still have work to do on this area, but the goal is in the future for this to be completely automated, so the ingestion pipeline will adapt depending on the load, the resources available, but that's planned for next year. Data loss, it's super important. The only two pipelines that we have a message queue system was Core and Nginx, but now we have support for pretty much everything. So we have the message queue system in place. Just keep in mind that not every single LON goes through a message queue system, but if the first write failed, it is put back in a queue and it retried indefinitely. Of course, this is because of costs. Unstructured logs, not surprised. We have thousands and thousands of services, dozens of programming language. It's really hard to impose any type of structure. So we had really good improved instrumentation, and Core is the one that will benefit the most. Thousands of different producers, I mentioned that a couple of times, but to mitigate this, we deployed an unified pipeline in best practice. If we go back to that diagram, you notice that every single layer is pretty much the same component list, so we don't have anything custom for any specific service. And we wanted to deliver better user experience than the current vendor, so we built Observe. And cost, surprisingly enough, everything that I just mentioned costs 50% of the current vendor. Right, lessons learned. What type of lessons we learned so far? And we know that we still have plenty. So everything works great until it doesn't. It sounds obvious, but It's not rare when we use an open source tool that the industry is happy about, but the moment we throw into Shopify scale and volume, it breaks. So it's not rare when we have to actually file issues back to the open source community. And of course, at some extent, we are contributing back just by finding these issues that only show up after a certain, I don't know, level of pressure. Testing is hard without production volume. It's really hard to replicate or mirror production data, especially because we would have to double the cost if you want to store and run the same type of workload. So it's really hard to test, but we are trying our best. And it has been very few occasions where we deployed something that completely broke. Transporting JSON is expensive. It's not surprise, but this is a trade-off that we made in order to to support the unstructured logs. We know that we have to transport duplicated data all the time, but at least right now, that's the current state. I cannot stress enough how much vector play a key role in this migration, especially in terms of the VRL support. That saved a lot of time coding and building anything, right? Because that allows us to do a lot of processing in the vector layer in terms of data enrichment, routing, parsing, and so on. So I cannot stress enough how important vector was. We are now 99.99% sure that ClickHouse can handle Shopify scale if you know what you are doing. The first time we tried ClickHouse, we didn't have the great experience, but over time we learned how to fine tune, and I believe right now we have a great product. Lastly, we learned that delivering an end-to-end product is key. So what that means is we wanted to give to the user the minimal experience possible with the pipeline that we have and access to the data. And then we can iterate fast and improve the product. So I cannot stress enough as well that how important it was to have the beta group and all the early adopters giving us feedback. The SRE team was great, so big shout out for them. And if the product that you saw today is what it is, it's because of these early adopters and their feedback. Cool, so we're almost there. So for future enhancements, it's not a surprise that we need to always optimize for cost. Just before I go into this list, I know there is someone in the audience. I don't want to put names, but his name starts with T. That is exactly like this every day. Every day we talk, I'm telling this person, hey, we should do some more refactoring, make it more effective. Right, Thiago? So yeah, going back to the enhancements, cost optimization is a never-ending project. We are always optimizing for cost, watching metrics. We want to keep improving resilience and reliability to make sure that our users rely on our product and they don't get in trouble for not finding their data. We need to improve. We need to make better automation to onboard new sources. There's a lot of manual tasks, including adding new indexes or new tables to ClickHouse and so on. But there is an ongoing project that will automate this. Cluster management is another thing that we really need to improve. Right now, we do a lot of stuff manual, but it's just the way it is right now. We have a path moving forward. And of course, I always have big plans for the ingestion pipeline. Okay, so here we are. I really want to finish this talk saying that this is a very short summary of a 2 years project that has a state-of-the-art team behind it. Thank you so much. Questions? Oh, Lord.
Hello. Cool. So you mentioned
that the cost was somewhere around 50% of the vendor. Are you ingesting more data? Is your retention period the same on that?
Great question, Elijah. Yes, we are actually paying 50% of the vendor cost, and I can tell you that we are ingesting maybe 3 times more log. I would say barely 3 times more logs, because before that we could not ingest all the edge logs, right? So when we move over to this new ingestion pipeline, the edge team could actually push 100% of the logs produced by Cloudflare into the new pipeline, which was not possible because of cost prohibitive reasons.
Thank you.
Yeah? Yes, sir.
Check. Yeah. So logs can definitely be where things go to die sometimes. I'm just wondering if with the new system, if you have like future goals of kind of tracking where there's some cost savings of like where waste is and things like that. If you can do that maybe better with this system.
Definitely. One project that we have in our roadmap is to actually work on the cost attribution, because there are many ways you can actually optimize costs, right? One is by improving CPU, memory, refactoring the code base that deals with the ingestion, and the other is working on the client side. So we want to give teams the ability to actually check for how much their logs are costing, right? Because I will not deny that there is a lot of noise in the logging pipeline. There is plenty of repetitive logs. They might not be so useful. So right now we don't have all the visibility because the solution that we have right now doesn't allow us to actually extract much of this information. But with the new pipeline, we can definitely work on how we give users visibility of their logs. And the core structure is one step further in this direction, because now they have so much metadata and information that we can actually track back who posted that log event at the log line level. So there are different places we can tackle cost optimization. One is the client who produces the log, the infrastructure, and storage. Did that answer?
Yeah.
Thank you.
We have a lot of junk too, so.
Right. And also we know all the queries that are executed on our system, which we've leveraged a lot already, right? I think is the other piece. So we know how people are querying data and what they're looking for, which is another avenue.
That's correct. I believe the team working on the search path has a lot of information to exchange with the write path, because we can optimize the write and the storage for the ways the users search for the information. There is no silver bullet that will work across all the tables and indexes. So we might have to optimize for certain tables like Core, Nginx, and Cloudflare, which are our top log producers. But yeah, definitely.
You've mentioned some indexes quite a bit, but you mentioned one called Core. What is Core?
Yeah, you can you can understand Core as every single log line that is produced by the Shopify repo application, every single component, everything that is inside that repository. Thank you.